Good afternoon. I am Rich Nass. I am the Executive Vice President of Open Systems Media, and I lead the Embedded Computing Design franchise, where we talk about anything that has to do with embedded computing, software, hardware, and everything in between. We're talking today with Aileen Ryan, who is the Chief Strategy Officer for UltraSoC, and we're going to be talking about security, specifically how it relates to the automotive space. Now, let me introduce Aileen first. Hello, Aileen.
Hi, Rich. How are you?
I'm great. So where are you based?
I am based just outside London in the UK.
Ah, hence the accent. I got it. Very good. Okay. So I took the liberty of looking at your slides real quick, and I noticed that you have in there the infamous Jeep, which we know has a lot to do with security and automotive, and the hack that happened, it's probably 5 years ago now. But that really garnered a lot of the spotlight just because it proved that there are ways to hack these vehicles that people never really thought of. So I'm hoping that's a good lead-in to your talk.
Yeah, the presentation that I've put together is about securing the automobile, as you said, but actually from an UltraSoC point of view, the same kind of technology could be equally applicable to other markets like avionics or precision robotics, etc. But let's focus on automotive. But in your imagination, think that how this would also apply to a number of other markets. So the first slide, as you mentioned, is the infamous Jeep Cherokee attack, and it's really interesting that this is known as the Jeep Cherokee attack because, of course, the attack was on an electronic subsystem which was bought from a vendor, a third-party supplier, but not the third-party supplier's brand name that is forever associated with this particular hack. It's the
Absolutely.
Jeep.
This is Jeep who owns that hack. No matter whose subsystem that went through, it's Jeep's name on there.
And so this is one of the reasons why security is incredibly important, in that it genuinely can become a share price affecting issue for automotive manufacturers, automotive retailers, even though the risk actually can accrue anywhere within their supply chain, within their value chain. And so the cybersecurity discipline and the links with functional safety have really come to the fore since this point because of the immense financial and brand impact of anything that occurs in this space. So, we see, for example, Mary Barra, when she gave her keynote address at the RSA conference earlier on this year, she was talking about how incredibly important cybersecurity is. We've seen Ralph Specht from Land Rover saying that in a connected world, actually cybersecurity is equally important as the brakes of a vehicle. And so there's really a light shining on the whole area of cybersecurity right now. And that's for a number of reasons. We know for sure that there's an inexorable trend towards increased levels of connectivity and increased levels of autonomy of vehicles. And those two factors introduce additional risk into automobiles and in fact anything that moves. So the number of electronic systems on board a vehicle is increasing all the time. They're incredibly complex, becoming more and more complex all the time. And the increased level of connectivity means that there's additional vulnerabilities way over and beyond any vehicle that would have been on the road 10 years ago. And additionally, the lifetime of a vehicle is really long. So, it can be in the design phase for anywhere from 2 to 4 or 5 years. And then it can be on the road for, usually automotive companies design with an expectation that a vehicle will be on the road for about 8 years. So you're designing now for a vehicle that could certainly be on the roads in 2030 and beyond. You really have no idea what the cybersecurity threat landscape is going to look like in that horizon. So anything that you can do today to provide additional protection on your vehicles is something that we're definitely vehicle marketplace. And we'll talk about the concept of defense in depth in a few slides' time. But really, I guess the key message here is that safety and security are rapidly climbing up the priority stack for automotive companies.
You raised an interesting point there about the length of time that a car would be out in the field. I believe you said 8 years, but I could show you examples on and on and on and on of vehicles out there for 20 years and longer. So is the automaker just saying, well, if it goes beyond 10 years, then we're not really at fault? How does that work?
No, I don't believe they're saying that at all. The 8 years is kind of an average amount of time that they expect a vehicle to be in life on the roads for. I don't think any of them are imagining that they will be free of liability beyond any point. So yes, they have to secure vehicles for the long term for sure.
Okay, just wanted to clear that up.
Yeah. So this slide talks about as a service, and what another trend that we're seeing in the marketplace, both from a retail point of view and a commercial point of view, is lots and lots of the emergence of lots and lots of different types of fleets. So whether they're fleets of taxis, whether they're fleets of delivery vehicles of any kind, I guess the ownership model related to vehicles is very likely to change in the medium to long term, and that's already happening in a number of examples today. And so, and we also know there's this statistic that I've seen where the cost of recalling a vehicle runs to, on average, again, an average number, $900. And if you consider how many millions of vehicles of any particular brand are on the road at any one time, that becomes a hell of a lot of money for the automotive industry to underwrite. And whilst vehicles are becoming increasingly connected, yes, of course, it's possible to change the software, patch the software, download a new version of the software that's running on the vehicle. But software is really only a very small part of the whole story of how vehicles work today and in the future. So the full picture and our mantra at UltraSoC really has always been, it's about the system. It's not about any individual component. It's about the whole system and how it works together. So yes, you can patch software, but software can't work without firmware. And firmware and software can't work without the underlying hardware. And guess what? You can't patch hardware. You can't download a new chip into the vehicle, right? So if there's a problem in that stack, at some stage, it's likely you will need to do a recall. And so one of the emerging trends that we're seeing is this ability that automotive companies are looking for, the ability to be able to track their fleets of vehicles on a very regular basis, daily basis, minutely basis, depending on the particular application that they have in mind. And then be able to correlate, okay, if I'm starting to see failures, or if I'm starting to see different kinds of non-optimal behavior in certain hardware systems or certain electronic systems, it would be much better for me to proactively do a scheduled recall. So the next time Rich's vehicle is in for a routine service, we're just going to change that chip and mitigate the risk that I can see brewing. I don't know when it's going to hit, but rather than have to do an urgent recall, I'm going to take things much more proactively and in a measured way and take out that cost per recall out of my business model. So protecting and monitoring all of the electronic systems on board the vehicle very regularly and correlating that data, being able to make predictions around failure rates and attack rates, etc., is something that we're seeing. It's effectively a new business model, and we are definitely seeing that start to happen now.
Very exciting.
The third slide I have is about cars are becoming computers on wheels, and so they're computers on wheels that travel quite fast sometimes. And when you consider planes, they're computers on wheels that travel way faster and carry a lot more people at the same time. And that's why a lot of the problems that we see or challenges we see in automotive are completely transferable and applicable to avionics and other industries. So cars are becoming, as I mentioned, really complex. So the first diagram here on the left-hand side of the slide is showing some of the types of electronic systems that we're seeing in vehicles today. So 100, 150, a couple of hundred different electronic systems in a vehicle is not at all uncommon already. And that starts to give you an idea of A, the complexity, and B, where some of the vulnerabilities might lie in vehicles.
Is it are becoming or have become?
So many, there, as shown in the Jeep Cherokee attack, which was in 2015, there are already many vulnerabilities in vehicles, but some of them, in fairness, are somewhat difficult to exploit at the moment. But the risk is that the cybersecurity landscape is morphing all the time, becoming more and more intelligent, becoming more smart. And so, we'll definitely be finding ways to exploit some of the vulnerabilities that exist and some of the vulnerabilities that inevitably will be introduced as we move forward, because it's impossible to engineer a perfect system. On the left-hand side, to your point, there are known vulnerabilities on vehicles. So Linux is a very common operating system on vehicles. QNX is the BlackBerry operating system, which is very important in the automobile sector today. And these came from, these numbers are already more than 6 months old, actually. And you can see the number of known vulnerabilities, and that's just in the operating system that exists on, that's being used on some of the chips. So those are things that have not been fixed, or at least were not fixed as of October 2019. They're known vulnerabilities. They can be exploited at any time, really. And so the industry is really running to stand still to keep up with making sure we are making vehicles and all of the electronic systems and vehicles as safe and secure as we possibly can. The next slide talks a bit about UltraSoC. So you probably know already, Rich, but maybe some of your audience don't know that UltraSoC produces semiconductor IP, so semiconductor intellectual property, which gets designed into chips at design time and is used when the chip is in the wilds, when it is deployed on vehicles or when it's deployed in wherever it's intended to be. And our IP is used to monitor what's happening on the chip. And we're not just monitoring software, we're not just monitoring firmware, we're not just monitoring what's happening on the CPU, we're monitoring what is happening on the system on chip as a whole unit. And I talked about that being our mantra, that it's about the system, it's not about any individual component. And so we gather data at hardware speed, so effectively in real time, nanosecond by nanosecond, and we're able to analyze that data and understand when there are things, let's say, going wrong, okay? So either behavior which is not expected to happen, or behavior which was expected to happen, which hasn't happened. And because we're in hardware, we're able to see those things incredibly quickly, fastest at the most rapid detection of abnormal behavior. And then we're able to do various things, raise alarms. In some cases, we're able to squash or prevent the propagation of certain things that we see happening. And we do that at hardware speed and in a non-intrusive way. So we don't interfere with what the electronic system was designed to do. Our system is entirely orthogonal to the normal reference behavior of the chip.
So to that last point, are you introducing any overhead into the chip at all?
No, so the analogy that our CTO likes to use is if you imagine a surveillance camera over a motorway, watching what's happening in terms of the traffic that's going by in either direction. That's the kind of analogy. So the security camera or CCTV camera over a motorway doesn't interfere with what's happening on the motorway, and that's the analogy to our technology.
Very good.
So I mentioned hardware timescales, and that is something that's really important. So if you detect that either a system is unsafe or a system has been hacked on a vehicle, and if you detect that in 200 milliseconds, let's say, that sounds like it's quite fast. But actually, for a vehicle in motion, it will have traveled quite a distance, 1.5 meters potentially at just 30 miles an hour in that period of time. So a couple of 100 milliseconds is too long in automotive timescales, and it's way, way, way too long in avionics timescales. So the fact that we are instantiated in hardware and we're looking cycle by cycle at clock speed at what's happening, and we're able to detect things in microseconds, if not less than microseconds, that's really meaningful for these types of scenarios. And in fact, I would go as far as saying it's a game changer.
So are you operating completely independently from the host processor? So it doesn't matter the frequency with which the host processor is running?
Correct. So we run at the clock speed of the chip. So whatever it's clocked at, that's what we will run at.
Okay.
So I mentioned the concept of defense in depth earlier on, and this is I think, a really important point, right? So I mentioned the benefits of UltraSoC technology. We're instantiated in hardware. We can detect things faster than any other solution that's available in the marketplace today. We don't interfere with the performing part of the electronic system, etc. So look, lots of tremendous benefits, but it's really important to say, this is not a panacea. There's no single security solution which can by itself protect every possible vulnerability that there is on a chip. So we do want to make sure our customers are always clear and work with them to make sure that they are implementing every potential security mechanism that they can. So this diagram talks about plant security, which in an automotive context could well literally be plant security from a manufacturing point of view, but it generally could be just physical security related to the vehicle. Network security, I talked about how increasingly connected vehicles are becoming. So all kinds of V2X communication. So not just communication within the vehicle itself, but between the vehicle and its environment in general. Lots of different technologies being deployed for different use cases. So network security is an absolute must. And then system integrity, this is really where we play. So we play in detecting attacks and responding to certain types of attacks in the most rapid way. And the reason why we constantly reinforce the defense in depth point of view is because, yes, of course you need to protect your perimeter. Of course you need to layer on as many different types of protection systems as you can. But coming back to the thought or the philosophy of vehicles are going to be used by human beings for a very long time to come, what if somebody breaks one of these layers? What if somebody, in 6 years' time finds a way to exploit a vulnerability in a way that they weren't able to before? Well, that's why you need to be able to detect in real time that your systems are actually functioning correctly. And that's where we play. So we augment the security stack, taking a defense in depth philosophy.
Now you say this is going below the operating system. I'm wondering if that's a little scary to the developer, because then the developer has no insight into what's really happening down there, and they're putting all of their eggs into the UltraSoC basket. Is that accurate?
No, I mean, so UltraSoC absolutely can expose data back up through the stack to anybody who needs to or wants
Okay.
to look at it. So yes, we can make decisions autonomously or in a way that has been designed in by engineers to begin with. But as the system changes, you can reprogram how the UltraSoC capability is working on the chip. So you can, for example, ask UltraSoC capability to change what it's looking at and give you more data or give you more insight into what's happening. But also we absolutely expect our capabilities to feed into all kinds of machine learning and AI algorithms that will be running elsewhere on the vehicle.
So the developer has the option of using a black box approach or not.
Yeah, that's exactly right. Yeah.
Okay.
My last slide is on a very specific project. So we were lucky enough last year to win quite a big grant from a UK government organisation called Innovate UK. And Innovate UK's remit is to find the most inspiring and forward-looking innovation projects, leveraging and bringing together academia and industry, and kind of underpinning the economic development of UK businesses in certain strategic areas. And cybersecurity is one of the key strategic pillars for the UK innovation economy in the future. So we won a grant in conjunction with two universities that you can see here, Coventry University in particular, the department where they are very expert in automotive, the University of Southampton in particular, the machine learning, computer science, engineering departments, and a small but extremely competent cybersecurity consultancy firm called Copper Horse, which is based in south of the UK as well. And so the project that we're working on is to build a demonstrator for the world's first on-chip monitoring solution to rapidly detect and resist cybersecurity threats. So we're about 6 months into that project now, and we're going to be able to demonstrate our first use cases by the end of the summer. So we're taking a very agile approach. We are building out use cases in conjunction with our automotive customers and our automotive prospects, and a lot of them have been really fantastic in terms of helping us understand where do their priorities lie and why. And so yeah, this project I thought would just be interesting to talk about, because it will be an example where we have a live demonstrator. Like it won't look like a vehicle from the outside, but it will look like the electronic systems inside a vehicle. And we're very excited about it in terms of proving out qualitatively and quantitatively what kind of threats can we really detect, how quickly can we detect them, how quickly can we mitigate them, and using the type of machine learning algorithms that you were alluding to that may be running elsewhere on the vehicle, or in fact maybe running in the cloud if you're talking about a fleet system. So how do we interact with those kinds of higher level systems to maximize the defense and depth capability of vehicles? That's the end of the presentation, Reg.
That was great. I really learned a lot. There's a heck of a lot more going on in that space than I was aware of. You know, you generally only hear when something bad happens, and you don't hear a lot about the innovations that take place.
Yeah, for sure. This is an area where there is a huge amount of innovation taking place. There are lots of, I talked about the Innovate UK project. There are lots of similar type of activities taking place all around the world, as you can imagine. The UK is not alone in terms of understanding that vehicles in general for mankind are, you know, they are a part of how we are as a society and how we're going to be as a society. and protecting them and defending passengers, defending citizens is critical.
Very good. That was Aileen Ryan. She is the Chief Strategy Officer with UltraSoC, and I'm Rich Nass with Open Systems Media. Thank you, Aileen. I really appreciate you taking the time to brief me today.
Thanks a lot, Rich.